All right, so today's lesson, we're going to be creating scatter plots and evaluating what's called a line of best fit. So success criteria, what you'll be tested on is, can you plot points on a coordinate plane? Can you create a line of best fit? Can you calculate and interpret the residuals? And can you estimate the correlation between variables on a scatter plot? So you should have the notes in front of you. No electronic devices, those should be in your backpack if I see them out. That'll be a detention. All right, but I'm recording right now. And then we have two videos here that are also helpful. The fitting a linear model to data, I'm going to show you how to do, but there's another example there if you want to see it. And then I highly recommend watching this video. I don't think we'll have time in lecture to cover how to do the same thing in Desmos, but it's really helpful if you want to learn how to use Desmos, since that's what you'll be using on your test. Otherwise, I'll show you how to do it by hand. The worksheet that you picked up from the back table, you're going to want to write the title of it at the top so that you know where to turn it into. So take 10 seconds right now and write that title on the top of the worksheet that you picked up today. So pencil in your hand, writing at the top of the worksheet that you picked up today. 6.06, scatter plots, day 1 practice. All right, once you finish it, it's going to go into that link that's in Schoology. And it's not evens or odds or anything. There's only one side to it. So no reason you can't get the entire thing done. All right, so just take 10 seconds, write the title, day 1 practice, 6.06 scatter plots, so that you know where to turn it in. All right, just reminding you, there's only 3 more tutoring days left. There's actually only 2, but I added one because I kind of felt bad for some people. But this is it. I'm not coming any other day than these 3 days after school. So if you've been meaning to retake something and there's no time in class, because you can retake stuff in class, it just has to be not during lecture, then it has to be those times after school. All right, you're just gonna have to make it work. There's not gonna be any other times. All right, retakes can only be done in person. If you email me the last week of school begging for the password that you need to pass this class, I'm not gonna give it to you because it has to be done in person. So here's fair warning that those are the last days to retake. Yes?
Do we need corrections or we have to retake?
You can do corrections if you want. I can tell you the Module 6 retake, which is scheduled for Thursday, May 13th, you won't have the opportunity to do corrections on that day. That one will be a retake. So if you were wanting to do corrections on that, we haven't even taken that test yet. But if you were wanting to do corrections on that, it would have to be before that day. All right, and then other deadlines for the rest of the semester. So deadline for late work from the pink folders, all the retake opportunities that we're doing in class. There's not a whole lot of wiggle room left. So if you're not going to be here that day, make sure you get it done in advance. I suggest, with everyone being quarantined and stuff, because you never know if that's going to happen to you, get it done earlier. All right, any questions? All righty, so then now on to the actual lecturing portion of the lesson. So we have 6.06 scatter plots and line of best fit. First thing, what is a scatter plot? I'm sure you've seen them before, and they're pretty easy to memorize what they look like, because it is a bunch of dots that are scattered, right? So scatter plot is a graph in which the values of 2 variables are plotted along 2 axes. The points do not connect. The pattern can tell you if there's a correlation present. All right, a correlation is a measure of a linear relationship between two quantitative variables. All right, so basically another word for relationship. So there can be positive, negative, and no correlation, and we're going to illustrate that here. So positive correlation, what would that look like? If something on my x value, on my x-axis is increasing, is the y value increasing or decreasing at the same time? Increasing. So like a scatter plot for positive correlation might look something like this. Right? Whereas one increases, so does the other. Again, scatter plots don't connect. So then negative correlation, as the x increases, what happens with the y's? Do they increase or decrease? They decrease. So your scatter plot might look something like this. What else? So like I think about it with like your positive and negative slope. It's really similar, except there's just no line going through them. At least not yet. All right. What do you think no correlation would look like? Yes?
So it wouldn't be like decrease or increase, it would just be like a straight line.
That's a good guess. Any other guesses? So it wouldn't be necessarily increasing or decreasing, but also wouldn't necessarily be a straight line. So it would be basically just a bunch of dots that seem to have no certain relationship, right? They don't have where it's increasing or decreasing. It's just random. All right, so positive, negative, and no correlation. So you can quantify that with something that is called a correlation coefficient. So we're going to fill that in right here. Correlation coefficient. Denoted by R. So like you might hear it as like your R value. And it varies from -1 to 1. All right, we use that value a lot in forensic science to determine if our data can be used, if it's actually useful. All right, so with the sign of R corresponding to the type of correlation, positive or negative. So if you have a strong positive correlation, then the R value will be closer to 1. If it's a strong negative correlation, it'll be closer to -1. And if there's no correlation, then it'll be closer to 0. All right, weakly correlated data will have values close to 0. Any questions on the vocab? All right, so we're going to apply what we just learned to these scatter plots. And these ones have what are called line of best fits drawn through them. So the actual data points are the dots, not necessarily the line. So for this first one, how would you describe the correlation? Positive, negative, or no correlation?
Negative.
It is definitely negative. And would you say that this is a strong negative or a weak negative?
Strong.
Strong, right? And how do you know that? Good. So like, since they're all going down almost like at the same rate, like they're all really close to that line, we can say that it's strong negative correlation. So if you had to predict that R value, what would you say that the R value is close to? Would it be closer to -1 or 1? And since it's a strong one, would it be like closer to like 0 or -1? -1. All right, so it's a strong negative correlation because the points are close to the line. And it's going downwards. So the R value would be closer to -1. What about this one here on the right? Would you say that the points are close to the line?
Yeah.
Good, points close to line. Would you say that this slope, if you will, is more positive or negative? Good. So points are the closer to the line with a positive slope. So how would you describe the correlation? Strong, weak, positive, negative? Strong positive. So strong positive correlation, I'll just abbreviate it. And if you had to predict what the R value would be closest to, so our options are this, -1, 0, or +1, what is the R value closest to? Closest to the positive one. Good. All right. Now the bottom left one, would you say that the points are close to the line? Not as much as like these ones up here, right? So I would say that they're loosely surrounding the line. So loosely around the line. And how would you describe like the slope of this one?
Negative.
So with a negative slope. So how would you describe the correlation? So the R value we could say is closer to 0 would be no correlation, right? Since we can tell a slope in this one, it probably won't be as close to 0. We could say that it's in between 0 and what? Good, so I'm going to change that. R is between 0 and 1, and -1, sorry. Because we know it's negative, but it's not as strong as the other one. What's the opposite of strong? So we would say that this one is weak, negative correlation. All right, I'll give you 30 seconds to try classifying this one down here on your own using like the context clues around it. Tell me on your paper, tell me if it's strong, weak, positive, negative, and predict the R value. Can you wait till later? So is this one strong, weak, no correlation? We would say it is weak, positive or negative. So weak, positive correlation, and I'll abbreviate it again. And what is this R value near or in between? Good. So R is between 0 and 1. All right, if you had to estimate an R value, like sometimes it does ask you like to give it a number. You can have like more than one right answer, right? Because you're just estimating. As long as it's between 0 and 1, and it's not like 0.95 where it's like really close to 1, maybe like 0.5 would be good, then you would be good on that. All right, any questions before we go to the next page? All right, so scatter plots, good. If you need to create one, you're just gonna be plotting the points. So I'm sure you guys know how to do that by now. Now we're going to talk about what are called trend lines or line of best fit. So a line of best fit, so that's the first point here. They're also called trend lines sometimes. Is a line through a set of two variable data that illustrates the correlation. So lines, like we saw on the first page, those are line of best fit. When there's a strong correlation between two variables, you can use it as a basis to construct a linear model. So if it's like really strong against the data, like we saw on the first page, I can use that line to help me predict other data points that are on there. When estimating the line of fit, you're going to draw the line that the data points appear to be clustered around. All right, so you're not necessarily connecting the dots, just drawing a line through the middle of the dots, where it looks like the dots are all clustered around it. It might go through some points, it might not. So it's not important that the data points actually touch the line. The line should be drawn as straight as possible, and the line should go through the center of the scattered points. Once a line of fit has been drawn on the scatter plot, you can choose 2 points on the line to write an equation for the line. All right, so step 1, we already have the trend line drawn out for us. But even if it wasn't drawn out for us, just draw a line through the center of the data. Just maybe use like the edge of your paper or a ruler. So draw it as straight as you can. And you're going to identify 2 points that appear to be on the line. And that doesn't mean that it has to be actual data points. Just 2 points that are on this straight line. So I would pick points that look like they're going through what's called like a crosshair. You remember that first semester? So like I would pick maybe this point and let's see, that point. All right, pick any 2 points that look like they're on the line. Pick ones that look like they're easy to read. You can even pick different points than me. Your answer might not be exactly the same, but it'll be really similar. All right, so those 2 points that I picked, can't really see them from here. So I have 15 for the x value on this point and 90 for the y value. Over here, what would this one be? What would the x value be? $55 for the x value, and the y value would be about 45, right? So here's my 2 points that I'm going to use. Because they appear to be on this straight line. We're going to calculate the slope. So taking it way back to first semester, do you remember how to calculate slope?
Isn't it like the rise of a
It is the rise over run. You can count it here if you want. Or what else could you do? Really close. That slope intercept form, that'll be the next step. Really close. Really close. y2 minus y1 over x2 minus x1. It's been a while, so I'm not surprised. But that formula, we can plug in these values. Just pick one of them to be your x1, y1, the other to be your x2, y2, and plug them into this formula. So plugging them in, my y2 we said was 45 minus y1, which we said is 90, over x2, which is 55, minus x1, which is 15. We could put this into Desmos, or we can just calculate it by hand. If you're using a calculator, make sure you put parentheses around the numerator and denominator. So 45 minus 90 in the numerator divided by 55 minus 15. And our slope is about negative 1.1. All right, did you guys get something similar? And on the whiteboard notes, which I will publish later, I used different points on the whiteboard notes and I still got this as my slope. All right, so you should get a slope near this, even if you use different points from the line. All right, so we found the slope. This is going to be my y, m, x, or b. M. So this is going to be my m in the y equals mx plus b. We don't know the y-intercept. It's not on this graph, but we can solve for it. So we have y equals mx plus b. The x and y could be one of the values that we use. So let's say I pick 15 and 90 for that x, y value. And then we had our slope as negative 1.1. If I plug it into y equals mx plus b, so my y is 90 equal to m, so negative 1.1 times x, which is 15, plus b, then I can solve for b. So negative 1.1 times 15, what would that be? I got negative 16.5 plus b. How do I get the b by itself? Really close. If it's negative right here, how do I get this to cancel to 0? So if I add 16.5 to both sides, that's how I get rid of it on the right side, which gets the b by itself. And then b equals 90 plus 16.5, which is 106.5. Miss Medina? Okay, no, fine. Okay. 106.5 is what I said for the b value. All right, and then to write the equation, we're writing it in slope-intercept form. What letters do we replace with numbers? Do we replace the y with a number usually? Do we replace the m with a number usually? Yes. Do we replace the x with a number usually? And what about the b? So then plug in your m that you solved for, plug in your b that you solved for. The line of best fit is y equals negative 1.1x plus 106.5. All right, and this is just an estimate. If you use different points on the line, you could get an answer that isn't exactly like this, but really close. All right, so just keep in mind, it is an estimate. So if you get an answer on your test and it's like really close to one of the options, you're gonna pick that one. All right, any questions about this? Questions about this right now? Okay, hold on. So you guys are gonna try doing the same thing down here. So you have a line of best fits. You're gonna go through the same steps that are written up here and come up with your own equation for your final answer. I'll give you about 2-3 minutes for that. All right, so down here, you could have picked really any points as long as they're on the line. It doesn't even have to be the data point, just from this line. What is a point that you use, someone? 0, 2. All right, so 0, 2. That's a good one to pick. What other one did someone pick? 1, 4, 5. About 1, 4 could have been another option, and 5, 10. All right, so again, they don't have to be the actual data points, like you see this one, that's at 1, 4. Even though that's not really the data point, it's still on the line, right? So I could have used any 2 of these points. The ones that I saw most of you guys using is the 5, 10, and 0, 2. But just know you could have used other points. They just have to be on the line. So I'll use this one in my example. If you use 1, 4, you don't have to erase anything. Just see if you got the same final answer as you did. All right, so first step is to, after picking the 2 points, to calculate the slope. What's the slope formula? Good. And does it matter which one of these I make my x1, y1 or my x2, y2? All right, it doesn't matter. As long as you don't like mix up the x's and the y's. So this one could be x1, y1. The other can be x2, y2. I should still get the same slope. So if I set it up like this, my y2 is 10, my y1 is 2, my x2 is 5, minus my x1, which is 0. All right, 10 minus 2 is, 5 minus 0 is, so I get 8 over 5. Normally I tell you to leave it as a fraction, but you could make it a decimal if you want. And it's 1.6 as a decimal. All right. What was I gonna say? If you use different points, your slope still should have been around 1.6 as a decimal. So then we now need to make our equation that looks like y equals mx plus b. And I'm solving for the b. So what do I plug in for y? You can pick either one of the coordinates that you use. I'll pick this one, but you could have picked the other one. Or if you did 1, 4, you could have picked 1, 4 and plugged it into here. So my y value, if I pick 5, 10, will be 10. My m is what we got from this. So either 8/5 or 1.6. What's my x value if I chose this coordinate? 5 plus b. All right, and then simplify. 1.6 times 5 is 8 plus b. How do I get the b by itself? I need to eliminate that positive 8. How can I eliminate it? Subtract it by 8. And what you do on one side, you have to do to the other. So 8 minus 8 on the right side, that's how we get the b by itself. And b equals 10 minus 8, which is 2. So we have our m, we have our b, and we are just going to plug it into this formula, y equals b. So y equals 1.6x plus 2. All right, and again, if you use other points, you still should have had an equation close to this. It doesn't have to be exactly the same, just close. All right, questions, comments, concerns? All right, I don't know if I want to start the next part. Let me see what it is. I'll come back to this page. Yeah, I'll save the residual stuff for tomorrow. So let's just do one more your turn, and then I'll give you some time to work on your big one practice. All right, it does not have to be the data points that you use, because what if there's no data points that are on? All right, so what are the data points that you use? What's one of them? That appear to be on the line. Did you say 21 and 170? All right, I would agree. That looks like it's on the line. So 21 and 170. What else? I would just pick one that goes through, say, like a crosshair, kind of. So like maybe that one. But you could have picked another one. Or we could even pick this one right here. All right, which one do you want to do? All right, so see, there wasn't a data point there, but it's an easy point to read that is on the line. So that's why I'm using it. All right, and that coordinate is going to be 20, comma 1. All right, now that I picked the 2 points, what do I plug it into? Good. And just FYI, I would not give you this formula on the test. This is something that you should have engraved into you. All right, but label one of these as x1, y1. Label the other one as x2, y2. And plug it in. So I have y2 as 180, y1 as 170, over x2, which is 20, minus x1, which is 21. Again, you could have used different points. You could have labeled this one x2, y2, and this one x1, y1. But your slope should be near what? Your slope should have been near 10. Even if it's a decimal, if it's a decimal that's near 10. All right, because 180 minus 170 is 10. 20 minus 21 is a -1, so it should actually be a negative. All right, questions on how we figured that out? All right, so my M is -10. All right, now I need to figure out what the B would be. So what formula do I use for that? Good. What value do you want to use for the Y and the X? Which coordinate? All right, so we're going to use this coordinate to be our X and Y. You can have picked the other one, that's perfectly fine. But we have 180 equal to M, which we said is -10, times X, which we said is 20, plus B, and solve for B. So -10 times 20 is -200, plus B equal to 180. How can I get rid of that -200? I could add 200 to make it cancel out to get the B by itself. And then what I do to one side, you do to the other side. So then 180 plus 200 is 380 equal to B. So that's our B value. We have our M value. Just put it together. Y equals -10x plus 3. All right, so even if you use different points, you should have gotten a line that is near this. All right, the slope could be a little bit different. It could be -10.1, -10.2, -9.9, something like that. And the y-intercept could be 379, 375, something near that. Yes? Oh, this right here, like this. Honestly, I'm not sure what that is. I'm guessing like maybe, I honestly don't know what that is, but no, that is. All right, any other questions? All right, so then if you have questions on your worksheet, let me know. You should be able to answer all of them. Maybe just one more thing I wanted to touch on. If I were to have to estimate, like this graph only goes up to like about 30 degrees. Well, if I wanted to figure out like how many maple syrup gallons we have at 35 degrees or something like that, then I would just plug in 35 for the X, that would be on the X axis, and the Y would be my predicted value. All right, or if they said, what's the temperature when I have 200 maple syrups, whatever, then I'll put 200 in for the Y and solve for X. So this equation that we made can be used to predict other values on that line. Question? Okay. All right.